All right, we're going to solve tangent squared x equals 0.36. We're going to solve for all possible values of x because notice they do not give us an interval over which to work. Now, the first thing you always do when you work problems like this is you solve for and isolate just the trig function with the variable in it. So in this case, if I want to undo this square, I can rewrite this first of all. Don't forget that this can be written like this. Okay, so now to undo this square, I just take the square root of both sides, but what that leaves me with over here is a plus or minus 0.6. Two equations now that we have to solve. So now we have to solve tangent x equals 0.6 and tangent x equals minus 0.6. Okay, now these numbers here are not numbers that you see as standard numbers on a unit circle. So we're just going to use the inverse trig functions to solve for this. So in this case, I'm going to take the arctan of both sides. So over here, x is equal to the arctan of 0.6. And over here, notice how I'm rewriting this. I'm not just trying to stick arctan inside in the other equation. It doesn't take that much longer. So this side over here, x equals arctan of negative 0.6. Okay. Now remember, if you think about your inverse trig functions, arctan is only defined between minus pi over 2 and pi over 2, not including the endpoints, because arctan is undefined there. So now, does 0.6 fall in those intervals? Yes, it does. Each one will produce one number from our calculator. So you go to your calculator. Remember, arctan is the same as tangent inverse. So tangent inverse of 0.6. Check to see in your mode if you're in the proper mode, and I'm in radian mode, which is what I want. I get 0.5404. 0.5404. Now if I do tangent of negative 0.6, I call up what I did before and insert a negative. Not there. Let's see, we want it right here. My goodness, I'm really struggling with this right now. There it is. So negative 0.5404. Now, just because this is the same number with the opposite sign doesn't mean it's always going to be that way, so don't be thinking things like that. Now, this is just one value that's going to show up within one rotation of the unit circle. Now, this number right here is a number that we know is going to show up in the quadrant 1. It's going to be our reference angle right here, 0.5404. And over here, this guy is going to end up in quadrant 4, where this is negative 0.5404. They're not going to be in any of these quadrants because that arctan is not defined in those quadrants. Same thing here. So now, if I want to calculate all the possible values for x here that makes this true, in order to get to the next one, or there is another one where the tangent of 0.06 is going to be positive, and that's going to be in quadrant 3 right here. Because sine and cosine are both positive here, or negative here, and sine and cosine are both positive here. So the other angle is going to show up in the third quadrant, where it has a reference angle of 0.5404. But that's just pi units away from this. So if I just add pi, I get to the next one. And if I add pi again, I get to the next one. If I add pi again, I get to the next one. So that's going to be all possible functions in the first quadrant, or in the every single rotation that solves my original equation. And here, the other quadrant where tangent is negative is going to show up in this quadrant here with a reference angle of 0.5404. Right there. So, in order to get from one place to the other, to get to all of the possible solutions, I, again, like the previous one, have to add pi. Multiples of pi. And again, k is an integer. There's a lot more to think about in trig equations than there are in, say, regular algebraic equations. But once you learn that, you just look for all the ones that exist in one rotation, and then you can always extend it from there. That's probably the most straightforward way of doing it every time.